Welcome to this demo video where we'll show how you build and test AI agent using Agent Loop in Azure Logic Apps. We build an AI agent for a coffee company to handle product return requests from customers. The agent uses multiple tools to automate this process, including fetching order details, analyzing images with a vision model, checking customer return history, and updating customers. If evidence falls outside preset decision boundaries, a human is involved in the review process. The agent dynamically orchestrates these tools to accomplish its goals. This continuous agent loop covers data collection, decision-making, action, and learning. Let us now implement this agent in Logic Apps using the designer in the portal. Developers can also do this in VS Code. We start by creating an agent workflow. This is a new kind of workflow that supports agents. After create, when you open the agent workflow, it has the placeholder for trigger and the agent loop action. We start by adding a trigger for the agent. Logic Apps provides hundreds of connectors that respond in near real time to events or signals like queue messages, new database records, file updates, and more. In this demo, the return request is received via email. We therefore add the Outlook trigger. Next, we configure the agent loop action. This agent uses an Azure OpenAI model for reasoning. The first step is to either create a new connection to Azure OpenAI or use an existing connection. After connection configuration, you can pick any AI model that's deployed in your AI service. Next, we provide the system prompt, which are instructions to the agent on its goals and instructions to achieve that goal. Along with what an agent should do, we also give instructions on where it should involve human, so that there are enough guardrails for the agent to operate and the high-risk decisions are still made by humans. Now we add the tools the AI agent can use for loan processing. Behind the scenes, these tools are added to the kernel object we created for the agent loop. To get customers' return history, we use Dataverse connector and then select the environment and returns table to get all the records. When you add a tool, the tool is wrapped inside tool block. Add all the details to configure the action you just added as a tool. Provide the name and description of the tool. This is a very important step to ensure agent understand the purpose of the tool. Let's add another tool. This time we add a nested workflow to analyze the images attached to the emails. We use this new API that we've implemented with a vision model. Once again, we provide the name and description for the tool so that agent understands the purpose of the tool. While tools are great for taking actions, agents often need to be grounded in knowledge. You can also add knowledge to your agent by choosing any of the connectors or through the curated list of knowledge sources here. We are building an autonomous agent. However, Agent Loop supports conversational agents too. To do that, you simply enable the channels for your agent, and then you have an agent which can engage in conversations. So, let's jump to this finished agent here. For human review, we use Teams connector with adaptive cards. This action is asynchronous and waits until a human response is received. For communication, we use the Outlook connector to send emails to customers about their return requests. Another key feature of Agent Loop is agent parameters. This is a powerful capability where providing values of parameters can be delegated to the agent. The agent supplies the values dynamically based on the overall goals, context, and the purpose of tool and parameter. As a developer, you specify the intent and the purpose of the parameter via a meaningful name and description. As a developer, I can focus on building the application while the agent loop handles the dynamic orchestration and execution of each tool, including error handling to achieve the goal of responding to a return request. Let's try the agent loop with some examples. In the first case, the customer wants to return a product because of poor packaging. Now, let's see what happens behind the scenes. Here is the Logic Apps execution which handled this return request. In the agent chat, we can see that the agent logs every decision it makes to fulfill its goal. For example, in this case, the agent chooses to use the image analysis, customer's return history, and the orders tools and runs them in parallel to collect data to make a return decision. For each tool, we can also see the inputs and outputs from during execution to get deeper insights. Once the agent has a final decision, it sends an email to the customer, completing the return process. Because the return is fully handled by the returns agent, the customer receives immediate confirmation that their return is accepted, leading to faster resolution times and higher satisfaction while reducing manual overhead for most returns. Let's look at another example. This return request comes from a customer with a frequent history of returns. Here is the Logic Apps run that's handling the return request. It's in running state. In the agent chat, we examine its steps in the execution logs. We see a few actions have been completed, but it's now waiting for human input via the Teams connector. The request shows up in Teams, and thanks to the supporting evidence that the agent has collected, the human reviewer can make an informed decision quickly. In this demo, we showed how a developer can easily build and operate AI-powered agents using the agent loop in Logic Apps. These agents can run securely in the cloud, on premises, and customer networks, and scale to handle complex scale scenarios.